Welcome back. Today we're jumping into part 4 of our series on chemical reactions. And we're going to master one of the most fundamental types you need to know for your Class 10 exams, the combination reaction.
Sometimes chemistry can feel like, just a huge, messy list of random equations, right? You work hard to balance one, and then a totally different one pops up. It can feel a little chaotic.
But here's the secret. It's not random at all. Once you've mastered balancing, which we've already covered, the next step is to start classifying reactions. And this is where the chaos starts to disappear, and chemistry becomes organized, logical, and way easier to understand. So, here's our game plan. We'll see how we can organize chemistry, we'll get to know the team-up reaction, look at a really important case study, take a quick break to refocus, and then it's your turn to solve a couple of problems. And of course, we'll see what's coming up next.
Okay, let's get right into it. So far, we've been focused on making sure the number of atoms on the left side of an equation perfectly matches the atoms on the right. That was all about balancing. Now we're going to shift our focus a bit, from just counting the atoms to actually watching the behavior of the substances. What are they doing in the reaction?
See, chemists are kind of like detectives. Over the years, they've noticed that reactions tend to follow certain predictable patterns. By looking at how the reactants, the starting stuff, turn into products, we can group them into a few major types. And this isn't just about being tidy, it actually helps us predict what might happen in future reactions.
We're going to kick things off with the first, and maybe the most straightforward type of reaction. I like to call it the team-up reaction. Its official name, the one you've got to use in your exams, is a combination reaction.
Now, this definition right here, straight from your NCERT textbook, this is pure gold. You should probably write this down and memorize it. The absolute key phrase to remember is combine to form a single product. You start with a few things, and you end with just one.
The easiest way to think about it is like this. You have substance A and you have substance B. When they react, they just bleep, join up. They combine to form a brand new single substance, AB. That's the pattern. If you can spot this pattern, you've spotted a combination reaction.
I mean, really, that's all it is. 2 or more reactants decide, hey, let's team up, and they become one single unit. It's basically teamwork, but for chemicals.
Theory is cool, but let's see how this works with a real example. And this one is a board exam favorite. We're going to dive into Activity 1.4 from your textbook, What Happens When You Mix Quicklime and Water.
Okay, let's break this down. Reactant number 1 is calcium oxide, a solid you might know is quicklime. Reactant number 2 is just good old water. Now, when you add the water to the quicklime, they combine, and they form just one single product, calcium hydroxide, which is also called slaked lime. Oh, and if you were doing this in a lab, you'd notice the beaker gets really warm. That means heat is being released.
And this equation, it shows us the whole story perfectly. Here's our A, the calcium oxide. Here's our B, the water. And what do? They combine to form our single product AB, calcium hydroxide. See? 2 reactants, 1 product. It's a textbook combination reaction. All right, that was a super important example. Before we test your knowledge, let's just take 1 minute to reset our focus. You see, a calm, sharp mind absorbs information so much better. So we're just going to do a quick breathing exercise. So just follow my lead. Sit up straight in your chair. Now take a slow, deep breath in for 4 seconds. 1, 2, 3, 4. Just hold it for a moment, and now a long, slow exhale for 6 seconds. Let's do that 2 more times. Ready? Good. Let's get back to it.
So you might be asking, why are we going so deep into this one type? Here's why. Identify the type of reaction is one of the most common questions you will see in your board exams. They'll just give you an equation, and you have to name it. Getting this first one right is a huge step toward scoring full marks.
Okay, it's time to put what you've learned to the test. I've got 2 practice questions for you, and they're designed to look exactly like what you'll see on your exam paper.
Here's the first one. A solution of some substance X is used for whitewashing. Your mission is to name substance X, write out its reaction with water, and then, the most important part, tell me what type of reaction it is. This sounds a little familiar, doesn't it? And for question 2, I need you to identify the combination reaction from these 3 options. Is it A, B, or C? Just look for that simple pattern, 2 or more things teaming up to form a single product. Go ahead and pause here to figure it out.
Okay, before we wrap up, let's lock in the essentials. For a combination reaction, remember this. You have 2 or more reactants. They come together to form one and only one single product. The general form is A plus B gives you AB. And as a little bonus fact, they often release heat, which means they are also exothermic reactions.
You see, when these concepts become crystal clear, your confidence for the exams just skyrockets. If this explainer helped things click for you, make sure to hit that like and subscribe button. We're going to be breaking down more board-focused topics to make chemistry simple for you.
So we've just mastered the team-up reaction. But naturally, that leads to a question, doesn't it? What's the opposite? What happens when substances don't come together, but instead, they break apart?
And that's exactly where we're going next. In our next explainer, we will explore decomposition reactions, where a single compound breaks down into two or more simpler things. It's literally the reverse of everything we learned today. I'll see you there.